Hi everybody, welcome back. Okay, well, I have the amplifier module put in, and now the fun task of putting all these wires back in is now upon us. I did end up going through and I replaced the two driver transistors and the diff pair transistors after all. And they all tested good. But I did notice that one or two of these ones, the gain was really low. I mean, they're low to begin with, like less than 100, but one of them was like down to 20 something. And I thought, well, it's time. They're getting tired. I'm just going to swap them out. And I replaced them with this one, KSC 3503, and the KSA, I'll have to look it up. And then these are the KSA 992 FBUs, and they're all pretty well matched, so I think they'll last a really long time. And also gave me a chance to clean all of the terrible glue off of those, because it was starting to eat away at the heat shrink, and on the transistor bodies and everything, the metal backs of them. So, and on these clips, so I cleaned them up. And those are pretty tight. These have little dimples in them that pop into the holes, mounting holes of the transistors, and clips them together really tight. So that's pretty cool. All right, so when I put these back on, I usually just get some pliers, a little bit more stout ones, either the duckbill or these ones, and I just put these back in here. I'll get this one pushed back, and then I'll wind it around like this, if I can do it here. And there you go. And well, this has been a fun project so far, but I'll tell you what, as far as if you are a first time restorer just getting into this might not be the receiver for you to work on, simply because there's a lot of things you have to take apart just to get to some of the simple things. There's a lot of other receivers out there that are a lot easier to work on than this one, that you don't have to take boards out and unwire things and everything to get into them. So, but you have to do it on this here. And I do have lots of pictures. I marked the wires, and hopefully that will minimize any mistakes. And mistakes do happen. The number one thing that you need to make yourself, if you're going to get into this kind of work, is a dim bulb tester. You definitely will need that. And some of you get hung up, by the way, on me wearing my wedding ring or wearing my watch or whatever. And yeah, I know you're repeating all the things you hear about, don't wear rings and jewelry when you're working with electricity, and that's all very good advice. But I definitely recommend that if that's how you feel safe doing so, you do it. I've been working on this a long time, and that's a stupid thing to say, because everybody says, I've been doing this for 100 years, and it's, and I'm good, and I don't, but truth of the matter is, yeah, okay, we can all brag, but honestly, I try to be safe when I work on this stuff. Yes, I may wear metal objects or jewelry or something, or do some things that may look unsafe, but I always have, either I have the power disconnected, I have pretty heavy current limiting on the device that I'm working on. There's always an angle to it, and well, you can still get injured. You minimize it that way. And yes, you can do all kinds of things. I'm sure you can wear insulated underwear and stand on a rubber mat and wrap yourself in rubber and everything else. I guess it's a matter of what you feel comfortable and safe with. I'm not going to use all the cliches on you folks. You all know that. But I do find it humorous sometimes when people get on that subject. But safety is a serious thing, though, in all reality. And I'll be honest, when we do our phase 1 training in X-ray, safety is a huge thing, and we spend a couple days on that simply because you're working with high voltages. You're working with objects that are very heavy, mechanically heavy equipment that can fall or pinch or whatever. We work with equipment that produces high levels of ionizing radiation. And yes, there are and have been and still are radiation-related injuries in this line of work, so it's very serious. So even though we try to joke around and have a lot of fun, we're also try to be careful as much as we can. And I'm just going to kind of randomly put these on as they get in my way to get them out of my way. So there's no particular order other than whatever's just easiest to grab at the moment. And if you notice, I'm just winding them back on. Sometimes you can do this, sometimes you can't. I mean, every now and then the wire just kind of gets work hardened, and when you bend it, it snaps, and then you just have to strip it back and start over again. And no, I don't use the wire wrap tool. If you try to use the wire wrap tool on wire that's already been wrapped once, it won't be much fun. Now, if you have enough extra wire to strip it way back and do it that way, and you want to use a wire wrap tool, yeah. But like I said in my last video, these binding posts are somewhat tarnished. So even if you twist them on there, you still want to maybe put a drop of solder on there to fix it up a little bit. But I just try to get it to look smooth on there, and I use pliers that do have some grip to them, and that kind of helps shine it up a little bit and get it ready for the solder, which is a good thing. Boy, did we have a difficult service call this week at work. They called the manufacturer in on it, and they couldn't fix it, and they couldn't figure out what was wrong, and they wanted to sell a whole upgrade, and it really wasn't like a rip-off job. It was the engineers were really having that much challenge getting the equipment to work, and they didn't know what to do, so they called us in, and we went to the site, and we just told them that, well, if the OEM that built the equipment's having troubles, it's probably not going to be easy for us either. But if you're willing to, let us spend the time, give us the time to work on it, and willing to pay for the amount of time it's going to take, then we'll do our best. And I got to admit, we did it. And I was very proud of, actually, one of my younger engineers just really did a phenomenal job breaking it down. I mean, he's trying to learn some of the electronics end of it. He's very good at the software and digital end of things, but he's really working very hard to get more versed in the digital. And boy, did he show up to the game this time. I was very impressed with him. And it's great to see your employees progress and get better and learn and succeed. And I'll tell you, it's a good feeling for them too when they actually fix something. I always joke with my guys at work. I'm going to tell them they're on probation all the time. They all say, well, when the hell aren't we on probation? I'm like, oh, there you go. Maybe one day. But gotta have fun. And it's cool in this line of work because you can get into so many different things. You can get into the hardcore electronics part of it, looking at transistors, integrated circuits and wiring and, schematics and all that. You can get into radiation physics, which is a really interesting topic, and digital imaging, computers, networking, and of course, CT or CAT scanners, MRI, cardiac cath labs, mammography, lots and lots of cool stuff to work on. So I enjoy what I do, I think we all do. Of course, sometimes when you have those ball buster problems, it's not always the most fun in the world, but it is fun, and it is really rewarding when you actually fix it, though, and when you figure it out. I'm kind of excited to get this thing powered up. The other thing is to power it up correctly so that it can be calibrated, and you can do the bias adjust and all that. You really have to have the whole thing installed. You can't do it sitting out on the bench. I mean, I guess you could, but it'd be a lot easier this way. So the other thing is, when it comes to stuff like this, there's really more than one way to do these things, as they say. More than one way to skin a cat, they say. Of course, don't let Mango hear that. She'll get mad at me and pee on my shoe. But yeah, it's funny. People do you're doing it wrong. I do it this way. Well, no, I'm not doing it wrong. I'm just not doing it your way. I get the same results. Are you all bored yet? Watching Mr. Magoo try to see stuff here. I was one of those kids that by the time I was, I think I was 9 or 10, I needed glasses. And of course, when I needed glasses back then, they didn't have the glasses they got today. These glasses today are awesome with these, high index lenses. I mean, they're like paper thin. And, the ones we all had to wear in school when I was a kid, looked like the bottom of a pop bottle. You get these big ass pieces of glass on your face. And not fun. In high school, I was a pole vaulter. I did pole vaulting, and not good for somebody that wears glasses, because I'll tell you, I got hold of a pole vaulting pole that had a double bend worked into it, and I got way up there, and the thing kind of shot me off to the side, and I went face first into the pavement, and had to dig some of my glasses out of my forehead. So there's blood running down my forehead. I'm angry and embarrassed, of course, when you're a kid in front of your friends. That's the worst thing, is when you get injured like that. So total anger. So I rage left the place and went home, and my next door neighbor was a nurse. And she was home, and by the time I got home, because I walked home, I got over to her house, I should say, there's blood running all down my forehead. It really wasn't as bad as it looked, but, when you get your forehead cut, you bleed a lot. And what happened? I'm like, just fix me up. So she cleaned me up and got a Band-Aid on there and everything, and then I went on home. And then had to explain to my mother what happened all over again. So, yeah, good memories. How in the hell did I get on that subject? Good grief. I'm fixing a stereo here, and we're talking about pole vaulting and thick glasses and pulling glass out of your forehead. Crap. Well, that's what you get when you watch my channel. This ain't one of them professional, educational channels. If you ever noticed and you looked at the topic of my videos, it always says entertainment, not education. Because again, yeah, I give you my opinion and my things that I work on and what little I know about this, and sometimes I talk as I'm learning and we learn together, but definitely in this particular genre, I'm not what I would call an educator. And you know, if you go through all my videos and see all the times I've screwed things up or said the wrong thing or did the wrong thing, you know, it's pretty amazing. But hey, if you can't laugh at yourself, you can't have fun when you're doing your hobby and things, you know, quit taking life so seriously. You know, I try not to. Not worth it. All right, let's see. How much time have I wasted just soldering a couple wires on a terminal? You know what I'm going to do? I'm going to finish this off camera before we get on some other weird tangent subject as I'm working here. And when this is on and get this all back together, we're going to fire it up and see how it works, or if it works. Okay, the wires are all in. I hope we can see the meter here. Let's get this turned on and get some connections. I don't remember. I think they want like 20 milliamps or 20 millivolts or something like that across those resistors, but we'll take a look here. I just want to see what we get. Somewhere I have the instructions, and then I could actually read them, but heaven knows. Okay, well, let's turn this thing on. I still have the bulb tester on there. It would help if I turned the power on, wouldn't it? Okay. Well, that's good. The bulb. Ooh, we got the relay. How about that? And we're at 55 millivolts. I don't know what it's supposed to be. I'm going to turn it way down, I can tell you that. And we want our 731 and 732 are the bias pots. But before we do that, let's look at the... push these in. I think that's speaker 1. Nope, that's not speaker 1. This is speaker 1. And I have a little bit of DC offset there. So, let's see if I can find a screwdriver. There we go. And I want our 712 and our 711. So there's 711, and I don't know which one is which here, but we'll see. So the first thing we're going to do is we're going to adjust the DC balance. We want to get that zeroed out first. So I'm going to turn this one. I don't know if I'm on the right. Yes, I am. And we just want to get that to be 0 volts at the center point between the transistors. So what that's doing is that's adjusting that center point to the speakers to be 0 volts. And then let's go to the other channel. It's not quite as far off. We'll adjust that. And that would be 712. And these pots are in really good condition. We got it right down to pretty much nothing. Okay. All right, so now we'll go over to the first bias test point. And that took it way down, didn't it? So I'm just going to leave that down low where it is right now, because once we put full power to it, that'll come up a little bit. They're both around 3 millivolts, which is good. And if I turn that up, I just want to see if it adjusts. Yeah, let's just turn it up to 5 just for fun. Oh, that's all we're getting. So it needs the extra power, because this one's turned up pretty far to begin with. And this one here, same thing. I might be checking the wrong. You may not want to test this with respect to ground also. I'm not sure how they want it tested, but that's all right. Probably should check it. Okay, well, that's a good starting point. And if you look, that's what we want. So that tells me that our amplifier is fixed and it's working, and we even got the relay to come in. And I did have to replace the power cord because there were all kinds of cuts in the old one, unfortunately. And I hate to do that because this one has that really nice Marantz logo on it. You can see, but there's just little nicks all along here I found. That let's see, where were they? Like where it went in, you could see it was kind of cut down there, and then going down along here there was another big cut right there, and it's just starting to wear through it, all of them. It's this cord's just was worn out, but a shame. Kind of like that, but brand new cord, so that should be good for a long time. And while I was in there, I replaced the lights. The panel lamps, there were quite a few that were burned out. Look how nice that is. Beautiful. Beautiful, beautiful. So this is going to be a nice receiver. And I got feet. And I got some buttons. Oh yeah. So she's going to be nice. Yeah, I couldn't resist. I just couldn't resist. I haven't cleaned any of the controls or anything yet, but as you can hear, I still have it on the current limiting bulb, but wow, it sounds good. It's working. Both channels are crystal clear, and I think this is a good start here. Okay, according to the instructions, because as you remember, our bias voltage was way down, or our bias idle current was down. I looked it up, and it's pretty simple. If you look here, it's just this little tiny adjustment, and you want to go across both emitter resistors. So that's going to be these two resistors right here and here. See these two 0.039s at 5 watt? Those are the emitter resistors for the outputs. And you can see I have that connected there. And if you remember, we're only getting, well, let's take a look. We'll turn it on. There's not much of anything right there now. And if you adjust R731, what they're saying in here is they want 24 millivolts DC. And if you do the math, we have two 39 or 0.39 ohm resistors in series, so 0.39 times 2, so that would be 0.78 technically, if everything was perfect, if these were perfectly on. And if you have 24 milliamps or millivolts, 0.024, divided by that 0.78, that would give you about 30 milliamps, you can see, of idle current. So they want about 30 milliamps of idle current on there. And you can see right now all I'm getting is 3 millivolts. And if I turn it as far up as it'll go, I can only get 9 millivolts. I can't get the whole way up there. Now, it looks like some changes were made in the design of this amplifier since the schematics were drawn. And there probably are some notes about it. But one of the things they did was they took this 160 ohm resistor, and if you look over here, they increased it to 200 ohms. You can see right there. And that's a 200 ohm resistor. That's the resistor that's in parallel with this pot. And that limits the range of how far this pot will work. Now, that probably was because they couldn't get enough bias out of it in the first place. And if I move over to the other channel, just to make sure there's not something wrong with this channel, and I measure it in the same manner, you can see that's about all I can get out of this one here is about 10 millivolts. Hold on, let me move it down so you can see. All I can get is about 10 millivolts there. And that pot's about maxed out also. So I think they had to do some tweaking on the bias circuit, and a lot of that has to do with the transistors that are used in the circuit. These are very low gain transistors, or they're lower gain. They're not super high gain. And so you need a certain amount of current flowing, from base to emitter in order to get the amount of current you need at the emitter collector. So let's just see if we have our half a volt there. And I'm just a little bit curious. I have some ideas of what we can do to fix this, but I don't want to try anything until I get a better idea of what's going on. So I may not get a whole lot done in this part of this video because we have to sort this out, and I think it would be a good thing to go through the process with you on this video. So that's what I'm going to do. Okay. So I'm going to move this over here so it's a little easier to see. And I'm going to bring this up here where we can get to the transistors. And what I want to do is I want to look at the emitter of both of these driver transistors here and here. So if I go to, let me see, there's the emitter of the, I believe this is the PNP or NPN, okay. We want a half a volt, and we do have half a volt, so the transistor is turned on even at that really low bias voltage there. And see, it's turned on there too. So it's plus and minus a little over half a volt, and they're saying that's what they want. So that's a good thing. It means that these drivers are on, but they are not providing enough current to the output transistors so that the output transistors can come up to their full potential. And let's see, they don't really give you the voltages for the outputs right here. But they're saying they want a half a volt at the base, which we have. And in the emitter, they don't really give you a voltage here, but that's where you want to see that 24 millivolts across those two resistors. So what can we do to fix that? Now the first thing we can do here, one option, would be to kind of take a page from their book and just increase the size of this resistor even more. So if it's 200 ohms right now, we can maybe raise it up to a 470 ohm resistor. So you'd have a 470 in line with this 1K. That might be just enough to get what we need. The other thing we could do is we could increase or decrease the resistance on this one. We can drop this down to like a 1K resistor or something like that. So I think the easiest thing right now is I would have to remove this resistor here in order to increase its value. But to decrease the value of this R723, which is that 2.4K, I can actually just jumper another resistor across it. So if I put, for instance, a 2.2 or 2.4K across there in parallel, that'll get us close to 1K. And that should allow us to get our bias voltage where we want it, at least in theory. So let's do that. So here is, I'm going to turn this way down. Let's see. And see, it is coming up a little bit, but I can't get it any further than that. It won't go to that 20. So I'm going to turn this way down. And I'll be right back. Let me get what I need. Okay, I just have a set of these little hook leads, and I grabbed a 2.2K. That's a 2.4, so it should get us just a little over a 1K resistor. So I'm going to do this live. Hopefully I won't short anything out. And we're just going to see what happens when I put this across here. Okay, and watch the voltage there. We're right now just around 2 millivolts. So if I go here, jumps up to 40. That's a little too aggressive there, I think. But I can turn it down. I can turn it all the way off. Now I have all kinds of adjustments. See that? I can go way up if I need to, but so there's your 24 millivolts, and that's perfect. So we're on the right track. I think the safer thing to do is to do what they did, and that is increase the value of this. What is that? 200 ohm resistor. Instead of like I said, instead of a 160, they moved it to 200. Maybe we'll move it to a 470, and that'll just give us what we need. Okay, I found some really nice metal film that won't drift with temperature. 470 ohm, 1 watt. And yes, they're smaller than before. I mean, newer transistors, or newer resistors, are physically smaller than their old counterparts. But that is a 1 watt resistor, which is more than enough for this. Now, I can remove the board and take everything back out, but I don't think that's going to be necessary, because what I'm going to do is I'm going to clip this straight out, just like so, right at the lead. And I'm going to clip this one right at the lead, like that. And I'm going to make these little standoffs. And let's see, my pliers are buried under my meter. I'm just going to take this and bend it out straight. I'm just going to make a couple little standoffs. Then I'm going to just eyeball the measurement of where I need to clip these off. I'm just going to clip off the excess lead length. And then I'm going to make a couple little hooks here. There we go. I'll put a little drop of solder on there. The first one's the hardest one to get started. There. I'm just going to tack it for now. That way I can get the other side lined up and get it neat. The idea is when you're done, you don't want it to be a big bodge job looking thing. I mean, try to make this neat as you can. And I will form the leads so they look a little bit nicer. Kind of like that. And there we go. So now we have a 470 in there. Let's see if that helps us out any. Move that so you can see. Alright, here we go. Oh yeah. See what that did? It's way up. See, and here's the problem with this method. You see how touchy that pot becomes? The more latitude that pot has, the more it will adjust, or more rapidly it will adjust across its range. So now the pot, it had a nice long, adjustment in it. Now it is very, very touchy. So I'm not real keen with that. See, there's 24, 22, there we go. I mean, it's not terrible, but I probably would be better putting a 330 ohm maybe in there. That might give us a little better latitude. I think I'm going to do that. Let's try a 330 ohm, because that's a little bit too much adjustment. Okay, I don't know if I was wearing my microphone the last clip or not, but we swapped it out for a 330 ohm instead of the 470, and that should give it a lot more gentle control and cut the range a little bit, because we didn't need that much. So let's turn it on. Okay, so there's 2 millivolts. So let's turn this thing. Perfect. You see that? That is exactly the amount of adjustment we need. And remember, you don't have to split hair with the bias adjustment. Remember that all the transistors are different. And even among, and you can see how this is heating up, you're getting some bias creep. You really have to let these warm up for 10 minutes before you adjust them. It'll start out low and it'll creep up, and then it'll settle. It'll hit its happy spot. But as I was saying, it wouldn't surprise me if this, well, of course, we were sitting at about 8 millivolts across those resistors, which is much lower, and it sounded really good. And the point is, the whole idea of the bias is just to prevent you from getting crossover distortion. If you cranking the bias up or having excessive amounts of bias, is just going to make the amplifier idle at a higher temperature. And there's no need for that. So once again, you can, as long as you're not getting any crossover distortion, if you make your bias a little bit lower than what the service manual tells you, it's not going to be the end of the world. And the other thing I'll tell you about that is that the instructions are always going to err on the side of caution. So they're going to set the bias to a level that no matter what transistors get in there during production, you're never going to have any chance of crossover distortion, because it's well above anything you would see in that transistor. So like I said, transistors are all different a little bit one from the other, so that's just to be expected. And if you watch while we were talking, see how that's creeping up? I call that bias creep. And that's going to happen with temperature as the transistors start to warm up. And these were staying totally ice cold before, because there was almost no bias on them at all. It was very low, even though we really didn't hear anything in the line of crossover distortion. And we didn't measure it with a scope. But I have a feeling if you did some critical listening, you may be able to hear a little bit. I don't know. That was kind of low. But I would think if this was idling at about 10 to 12 millivolts, which is half of what they're recommending, it would probably work just fine. These transistors seem to be pretty good. And again, see, it's creeping up. And this is going to happen for a good 10 to 15 minutes. You really can't, and even with that, when you turn, I still have a current limiting bulb in there, even though it's hardly limiting anything at all. I only have 117 volts going into this amplifier instead of 120. And I suppose we can go to direct right now. In there, see, it jumped up a little bit more. Not much, because I was already at 117, now it's at 119, 120, so only 2 or 3 volts difference on the mains. But we're just going to let this sit here and cook. And feeling these, they're totally cool. There's no heat at all. I guess these ones are now at room temperature, or maybe a little bit above. I can kind of imagine. And this one is just slightly warmer than this side, of course, because the bias is a little bit higher. So if I'm happy with how this works, and this holds and locks in after 15 minutes, I'll go ahead and replace the resistor on the other side in the same manner, and that will get our bias circuit into the range it needs to be. Again, when you replace transistors, these are things you might run into. You can't just willy-nilly substitute, even with a substitute transistor that on paper is the same, it may not be. Always remember that. You have to test things. Don't just go Google search something and somebody in some forum says, I used this transistor. You still have to check to make sure that what you're doing is going to work. Same as this. I did this. Don't just copy me. Do your research. If you're going to do this, test it. Make sure that it works properly. I could be wrong. It's very possible. I'm doing this as we go along here. I'm not, I'm not staging this. I'm actually testing this as we go. So there could be something that I did wrong that I don't know yet. And that's a lot of these videos and a lot of these forums that you see online. You run into that sometimes. Some people are very knowledgeable and have done this before and can speak from experience, but you just don't know. You just don't know from the internet. You can't tell who's on the other end writing that. Okay, it's been about 20 minutes now, and I backed the bias off to around 20 millivolts, and now you're going to see the action of that thermistor and the stabilizer and all that. You'll see this will creep up a little bit, and then it'll kind of creep back down. See that? It went up, and it'll go back down, and it'll just sit there. See that? That is the sign that your bias circuit is working properly. Everything's kind of keeping everything in tab. And I'm going to leave this at 20 millivolts. I don't see a need to have 24 millivolts on there because I think these transistors are close enough that, you're not going to get any crossover distortion. So I like this. This seems to be working. So for me, I'm going to take this other resistor here, do the same thing on this channel, go through the same process of adjusting it, and we can know with confidence that this this amplifier is working the way it was supposed to. Okay, the other channel is done, and I have it floating around 19 millivolts instead of 20, but you can see it goes up and down. It's doing its thing. And in retrospect, I still have a good bit more adjustment than I need. Just adding, going from a 200 to a 330 ohm. In retrospect, I probably could put a 270 ohm resistor in there, and that would have been enough to get more than enough to get what we need. So, yeah, I mean I'm not going to change this, but that even a 270 would have gotten enough adjustment out of this that we could get our bias where we need it to be. So, and again, I haven't had this running for 20 minutes yet, but it's stabilized. It's still creeping a little bit. You can see it's going up. So maybe after a few more minutes it will hit 20 and then it'll just kind of stop. But it's taking its good old time right now. So I think we're just about at equilibrium where we need to be. So if this is good, then I'm going to play some music again and just take a quick listen to it. None of the controls, none of the preamp, tone control, nothing has been serviced yet other than the amplifier and power supply. The other thing that I want to look at, well, actually I looked at it already, I want to show it to you, is the low voltage power supplies. And they are absolutely perfect. I really didn't have to touch the adjustment hardly at all. But there is that 35 volt power supply is adjustable. You can, I'm going to just grab ground over here. And here's the 35 volts. You can see it's like right on 35. And that's what this pot right here does. That adjusts your 35. There's also, I think, a 9 volt and a 14 volt. So if I go down here, this one is the, yeah, it's 9.8 volt. And then this one, I think, is, yeah, 14. It's supposed to be 14.5. It's 14.3. That's good. So all of our regulated supplies are really good. And remember, that 35 volt supply directly controls your bias circuit. So you want that to be stable, because if that moves, it's going to move your bias a little bit. So having it, you know, be regulated like that makes a big difference. Okay, well, let's spin it around and do some play the music again. All right, I'm going to turn the speakers back on, and I am going to play that same song that I played here earlier. Let's see what we get. Yeah, I think that's good. Nice. And even though the knobs are all out of sorts, they are all centered. Even though they don't look like it, because they're all out of whack the way they're on there. I'll have to clean them, and I don't think I'll have to replace any of them, but they sure are. They look like they've been glued or something at some point in time. But we'll sort that out later. That's cosmetic. I'm pretty impressed. It's working very well, and it's sounding good too. Well, there it is. Looking good. And I did replace these bulbs, and because they're just kind of hard to get to once you get everything all together and all. So I put the LEDs, and in this case, these have the blue filter in front of them, you know, the filter paper or whatever you want to call it. So I just put the warm white lights in the back, and they match that. They look really good. And for the dial indicators, they don't have that. So they want you. So those bulbs actually had the blue frosting on the glass that was really worn out on them, and one of the bulbs was out and everything. So I replaced those with the cool blue LEDs, and they match very closely. So I think I'm happy with that, and it's not too bright or, you know, harsh looking. Again, I want this receiver to look really good. So the next thing I'll do is we'll take the faceplate off, clean everything, and then we'll start getting to work on the tone control, the phono stage, and all that. And then the final thing we'll do is the tuner. Didn't really get in this video part to what I wanted to. I wanted to get into that, but I think this whole modifying the bias circuit and everything was important enough that it's worthy of its own video. So I'm going to end this one right here. I'm going to wish you all peace, joy, happiness, and good health in your lives. And until the next segment comes out on this series, take care, everybody. Bye-bye.